Hey everyone, welcome to This Explainer. Today we're diving straight into the evolution of the Ethereum name service. We're going to trace its journey from its early Web3 roots all the way to the enterprise-ready ENS v2 upgrade. We'll see exactly how a tool that was originally designed just to make sending crypto a little easier is actually transforming into the fundamental identity layer of the decentralized internet. So think about this for a second. It's a simple premise, but it's what drove the creation of this protocol over 7 years ago. Imagine if the random string of characters you use to receive funds could also serve as your login, your website address, and your public profile. I mean, that was the spark that really ignited ENS. Here's our roadmap for today. We'll start with the blockchain phonebook, look at the global identity namespace, discuss the limits of flat registries, and then we'll get into ENS v2 with hierarchical registries, instant subtree management, and finally, those 32 roles for enhanced access.
All right, part 1, the blockchain phonebook. You all know the standard 42-character hex address. It's intimidating, practically impossible to memorize, and honestly, highly error-prone. One typo and your funds vanish forever. No way around it. But then you have a human-readable name, like alice.eth. ENS steps in and transforms that complex machine identifier into a simple, recognizable NFT-based name using the ERC 721 standard. You just type in a name, and the blockchain knows exactly where to route the transaction.
So how does this actually work? It's basically 3 invisible steps happening automatically on-chain. First, you enter the name. Then, the ENS registry, which is essentially a central smart contract, looks up the owner of that domain and figures out where its data is stored. Finally, it points to a resolver contract, and that resolver does the actual heavy lifting of translating the name into your Ethereum wallet address. Moving on to part 2, global identity namespace. Now, what's really fascinating here is that this namespace acts as a highly extensible cross-chain identity anchor. It's not just a nickname for your Ethereum wallet anymore, right? It's evolved into a universal protocol designed to map human intent to machine state. And it does this without relying on centralized servers or authorities. Because ENS purposefully separates the central registry from the resolvers, a single name is incredibly versatile. Literally, one domain can route payments across multiple blockchains, meaning your ENS name can hold Bitcoin, Litecoin, and Ethereum addresses all at once. You can host censorship-resistant websites on IPFS through a content hash, or store profile metadata like avatars. You can even bring your legacy Web 2 domains like your traditional .coms into the ecosystem using DNS-sec integration. It's the whole shebang, a unified identity across the entire Web3 space. Which brings us to part 3, the limits of flat registries. With ENS version 1, everything lived in one giant registry contract. It was incredibly elegant in its simplicity, for sure. But as over 1.5 million names were registered, it hit some major structural roadblocks. It meant every single name had to play by the exact same rules. Organizations that needed custom logic or specific governance structures for issuing subnames found themselves completely boxed in by the rigid constraints of this one monolithic contract. So that limitation sparked a massive architectural shift. We're talking about moving from a rigid system, kind of like a stack of bricks, to a dynamic, growing tree with ENS v2. Instead of forcing everyone into one massive ledger, v2 distributes the power. It shifts from a flat structure to a hierarchical registry, allowing for infinite modularity and customizable ownership models. Let's dive into part 4, ENS v2's hierarchical registries. In v2, every single name is essentially its own isolated ecosystem. If you own a name, you can deploy your very own specific registry implementation just to manage your subnames. And these subdomains are now managed as highly efficient ERC 1155 singleton NFTs, which saves users massive amounts on gas fees while keeping provable ownership intact. To make sure this doesn't fragment the entire network, they introduced a universal resolver. It acts as a single entry point that handles all the complex, recursive lookups across these independent registries automatically. This opens up some wild new capabilities. Think about shared registry architectures. This means a corporation could manage subnames across multiple different brands simultaneously by pointing them all to one master registry contract. Imagine a DAO applying the exact same governance rules to both team.dao.eth and community.dao.eth at the same time, without having to duplicate their efforts or pay extra gas. Next up, part 5, instant subtree managements. Picture this. You're managing a community DAO with 1,000 members, each with their own subname.
If your membership criteria changes, in V1, you'd have to pay gas to manually revoke every single one of those names. But in V2, an organization can instantly swap out the entire subtree in a single, highly efficient operation. You just deploy a fresh subregistry, update the root pointer on the parent name, and bam! In one lightning-fast transaction, the old subtree is completely replaced. And here's a massive security upgrade: immediate expiration. Basically, when a branch breaks, the leaves go with it. In the old system, if a parent domain expired, its subnames sometimes hung around like ghosts. This created dangerous zombie records that bad actors could exploit. Because V2 relies on a true hierarchical tree, if a parent name expires, that connection is instantly severed. The entire subtree vanishes at the same time, ensuring a clean slate and protecting users from abandoned identities.
Finally, Part 6, 32 roles and enhanced access. 32. That is the magic number here. ENS v2 completely overhauls the old, highly complex name wrapper fuses system and replaces it with what they call enhanced access control. This system features exactly 32 resource-scoped roles, and each one of those is paired with a specific admin role that can grant or revoke it. The granularity here is just off the charts. Organizations can now set permissions at the resolver level, the name level, or even drill down to the individual record level. That means you can safely delegate specific tasks like, say, allowing a marketing manager to update a single IPFS website text record without ever giving up ownership or admin control of the underlying name itself. It's literally enterprise-grade role management built right into the blockchain. So what's the big takeaway? As this quote hits the nail on the head, registering an ENS name isn't the destination, it's the foundation. Ultimately, as the internet becomes fully programmable, an ENS name evolves from a simple personal alias into a robust, portable coordination layer for entire institutions. It's about anchoring your identity, managing access, and organizing communities securely on-chain. With ENS v2 providing this insanely modular, hierarchical infrastructure required for complex digital identities, the limits of what you can create are practically non-existent. The tools for robust decentralized governance are right there at your fingertips. The only question left is, how will you architect your own on-chain empire? Thanks for exploring this with us, and we'll see you in the next explainer.